Okay, I want to conclude the section 8.3 notes, and as you can tell by the title, we're going to learn how to graph log functions. And to introduce this, you don't need to write what's on this screen. I'm just using this as a way of connecting something that we've already done that you should be familiar with, and how that applies to what we're about to do with the graphs of log functions. So what I've done here is I just copied and pasted a problem from your last quiz, which most people did a really good job with. You had to graph the relation, so that's obviously, since it's quadratic, that's a U-shape or a parabola, and most of you successfully said that the relation looks like this. And then raise your hand if you can tell me how we graph the inverse of that. JT?
You would switch the x and the y in your equation and solve for y.
Now, if we wanted to get the new equation, that's true, but what if I just wanted to show what the inverse graph looks like?
You would switch the x and y coordinates in each of your order.
Exactly. So I would take each one of these ordered pairs, and I would take 0, 4 and plot it as 4, 0, 1, 5 becomes 5, 1, and so forth. And that's a review of what we did a few sections ago. Well, I'm doing this because when we graph, don't write this, but when we graph log functions, I want you to take away today that the graph of a log function, like I have here in red, is the inverse of its related exponential growth function. Okay? So I want you to see, before we actually get into doing this, if I do a table for the exponential growth function, y equals 3 to the x power, and we've done several of these in past homework assignments recently, we know how to get this table. Well, if I just take those ordered pairs and switch them, just like JT said on our previous problem, to get the inverse, that results in the graph of the log function. So the takeaway from the first part of this lesson is log functions are inverses of exponential growth, or it's the same would be true if we had exponential decay. If we know the table for the exponential growth or decay function, then just switching the xy coordinates and plotting those will give us the graph of the log function. Okay, so now we're going to actually work one. This is what you need to put on your graph paper. So let's walk through how we would graph, and this matches up very closely with your homework problem number 36. Let's sketch the graph of the function y equals log base 4 of x. Well, the first thing I'm going to do, just like we looked at earlier, I'm going to come up with a table for the exponential growth function y equals 4 to the x power. So you can think of it this way. It's like taking the log equation and raising whatever the base of the log is to the x power, and that's how you will get the either growth or decay function to get a table from. Okay, so everybody see that? All right, just like we've been doing, I went ahead and filled in this table for you. I'm kind of going fast on this part because this is really review of sections 8.1 and 8.2. All right, any questions on how I got this table for y equals 4 to the x? Okay, well, to get this log graph, I'm going to take this table of values and switch the xy coordinates. And when I do, it's kind of hard to see down here in the bottom right hand corner, but switching the xy coordinates for y equals 4 to the x power gives me the coordinates for y equals log base 4 of x. And on my next screen and on your graph paper, I need for you to go ahead and plot these 5 points here at the bottom. And I'll show you on the next screen what our curve should look like. Now I'm going to tell you ahead of time that the next slide contains more than what you are going to be required to do tonight. I've done some extra stuff just to relate today's lesson to what we've done previously. So I'll explain exactly what I want your homework to look like. All right, so what you should have after you plotted those points from that bottom table, you should have something that looks like my red curve. Okay, raise your hand if you were able to get that. All right, that's good. Now the blue is not required tonight. I'm just using it as an illustration. This is the growth curve from section 8.1. The green line is not required. I'm just reminding you, we had this discussion earlier, how that when we do an inverse, that always reflects over this line, y equals x. That's always true for any inverse of any graph. Inverses will always pick up and flip over this line, y equals x. So tonight, you do not have to draw this curve. You do not have to draw this line. I want you to draw the log graph, which is the red. And I also want you to notice how we now have a vertical asymptote instead of a horizontal. Exponential growth, we talked about how it had a horizontal asymptote, which is the x-axis. But when we flip over y equals x and we sketch the log graph, we now have a vertical asymptote, which is the y-axis. So tonight, in addition to drawing your curve, I need for you to point to the, in this case, you would point to the y-axis and you would put VA instead of HA. All right, so I'm going to pause for questions. Any questions on how we got the log function graph? The inverse of exponential growth or decay. Just happened to be growth in this example. Okay, now I'm not going to do the entire graph of this next problem, but I'm just going to get it set up for you. All right, so what this relates to for your homework will be these two problems. Same idea, except this function represents a translation. Somebody tell me what the -1 in the parentheses being subtracted from x, what does that tell me about the shift of the parent function?
It's going to be to the right one.
Very good. I don't know if you heard that, but he said we're going to shift the parent function right 1 according to this. And then what does the +2 tell me?
Goes up 2.
Up 2. Okay. Well, let's just start with just like we did before. Let's make a table for the growth function y equals 5 to the x power. Do you see where I got 5 to the x? The base, just think of whatever the base of the log is, raised to the x power. I did it in blue so you can kind of see how it stands out. All right, let's just run through that real quick. If x is 0, y is 1, 1, 5, 2, 25, -1, 1/5, -2, 1 25th. Now that's the growth function y equals 5 to the x. Well, how do I get the log function y equals log base 5 to the x, or log base 5 of x? Yeah?
You inverse the points.
Exactly. He said, he used a good word. He said the inverse of that exponential growth function is the log function. So we're going to switch the xy coordinates in this table. 1, 0, 5, 1, 25, 2, 1/5, -1, 1 25th, -2. Okay. Now my final step is going to help us account for the translation. So you guys said earlier that we're going to shift right 1. So how do I show a shift of right 1 in this table? Add 1 to the x's. So I'm not going to show it here, but Does everybody see how shifting right 1 means all of these x's need to have 1 added to them? Now how do I account for the shift of 2 places up? Add 2 to the y's. And when you finish that addition, 1 to every x, 2 to every y, that's the table you're going to be graphing. You plot those 5 points. Now I'm going to show you what the finished product looks like. If you don't want to take the time to do it, that's okay. Just trying to save a little bit of time here. But first of all, just raise your hand if you're not sure how we accounted for the translation. Why did we add 1 to every x? Why did we add 2 to every y? Is everybody clear on that? Okay. Now, here's what your log function should look like. I just plotted those 5 points after adding the 1 to every x and the 2 to every y. Well, notice what happens since we shifted to the right 1 place. What is our vertical asymptote now? Before the shift, it was right here. Now, shifting right 1 place means we have a new vertical asymptote, which is the line x equals 1. And technically, I went just a little bit too far with my curve because, remember, I should be always approaching that line but never touching or crossing. So I need for you to show me that on your homework tonight. In addition to the curve, you need to tell me what the vertical asymptote is. You're going to have a vertical asymptote for the log function versus a horizontal for the exponential growth or decay. So, any questions? Yeah.
Will we ever have to graph like a log function without looking at its inverse, the exponential?
Well, I would suggest you always go through that because it's just easier. Otherwise, you're going to have to just substitute numbers in and then evaluate the log. And that's probably going to be a little tougher to do. It's possible. It would be, you're going to have to pick some good numbers, though, where the log could be evaluated easily. I just think it's easier to think of the growth being the inverse, log being the inverse of growth. Okay? All right, so we're going to close the book on section 8.3, and just a reminder, we've already talked about these. Yesterday's lesson covered 6 through 25. If you need to go back and watch that video, it's there. It's on Moodle to get a reminder of how to evaluate logarithms. What I've just covered will help you with those 3 graphs. Okay, so just contact me, email me if you have any questions. We'll check those tomorrow.